Previous lecture, we have seen types of sets and Venn diagrams. And in this lecture today, we'll see operations on sets. We have seen the operations on numbers, like addition of two numbers, subtraction of two numbers, multiplication of two numbers, and division of two numbers. Similarly, in sets, we have operations on sets between two sets. So let us see what kind of operations we have in sets. Let's discuss them one by one. So let us start with the first operation that is known as union of two sets. So first operation will be union of two sets. Union of sets. A union of sets, if we have any two sets, let us say set A and set B, then their union is a type of operation which is a new set such that it contains the elements of both A and B taken once. Let us say, for example, I have set A. Let us say set A is equal to, let us say, for example, 1, 2, 3, and 4. Let us say I have set B, its elements are, let us say, 3, 4, 5, and 6. Then their union, that is A union B, it will be a new set such that it contains the elements of both A and B, each element taken once. If I see the elements of A are 1, 2, 3, 4, and B has 3, 4. Since 3, 4 is already present, so we'll take just them at once. And then we have 5 and 6. So this A union B, it will be a new set such that it contains elements of both A and B taken all once. So this is known as the union of two sets. Now in set builder form, if we want to write this union in set builder form, we can write like this. A union B is equal to set of all x such that x belongs to A or x belongs to B. So this is a representation of union of two sets in set builder form. That this union is a new set such that it contains elements x such that x belongs to A, x or x belongs to B. So we'll take all elements from A and B. So this is a representation of union of two sets in set builder form. Now let us see some properties of union of sets. The first property, let us see now the properties of unions of sets. The properties of union. Properties of union of two sets. The first property is that A union B is equal to B union A. If we take A union B and B union A, we'll get always the same set. This is the first property. And let us first see the before properties. Now let us first see how in Venn diagram we represent the union of two sets. Let us say this is a universal set. Let us say it has two subsets, set A and set B. It is set A and set B. Then A union B, it will be elements of both A and elements of both B. So this will be the union. So the union A union B will be all elements of A and all elements of B. Now if we take A union B or B union A, we'll always get the same set. Second property. The second property is that is known as associative law. It is known as commutative law. It is commutative law. Now let us see associative law. It says if we have three sets, let us say A, B, A, B, let us say I have three sets A, B, and C. If we take their union, A union B union C. Now since it is a binary operation, it is a union. Let us say first I will take the union of A union B, and the set that I will get, then I will take the union with C. I can see that if I change this sequence, If I change this sequence, let us say I will take first the union of B union C, and whatever set I will get, then I will take the union of that with A. Always I will get the same set. This is known as associative law. So it means that in three or more than three sets, if we change the combination of union, we are taking different two sets first. First we'll take the union, and then the result that we get, then we'll take the union with another set. Always in different arrangements, we'll get always the same set, same result. That's known as associative law. Now let us see the third one. The third property is A union phi. Let's say I have A, I take union with phi. Since phi has no element, if I take A, it will be equal to A because phi has no element. So the union of A and phi will be always A. It is known as identity law. The fourth property is A union A. If I have A, if I take union with itself, simply I will get A back because I am taking the both elements of A only. So it will be simply A. It is known as idempotent law. And let's see the fifth property. The fifth property is that if I take a union set, universal set, and I will take the union with A, universal set, union with A. Simply, I am taking the all elements of universal set and A, simply I will get complete universal set back. So it's known as law of universal set. So these are the properties of union of two sets. Now let us see intersection of two sets. So now let's see the second operation that is known as intersection of sets. The second operation is known as intersection of two sets. Intersection of two sets. The intersection of two sets is a new set which contains elements, only those elements which are common in both these two sets. Let us say I have two sets. Let us say set A. Let us say in set I have elements 1, 2, 3, and 4. Let us say I have second set B. It has elements, let us say 2, 4, 6, 8. Then A intersection, this is not an intersection. Then A intersection B, it will be a new set such that it contains those elements of A and B that are common in A and B. I can see 2 and 2, it is common. 4 and 4, it is common. So it will consist of 2, 4. So the intersection of two sets is a new set which consists of elements, those elements of two sets that are common in those two sets. Now, if we want to represent this intersection in set builder form, I can write like this. A intersection B, A intersection B is equal to set of all x such that x belongs to A and x belongs to B. That is those x elements that are in A and B also, common elements. So this will be the representation of intersection in set builder form. Now, if we see this intersection in Venn diagram, how can we represent in Venn diagram the intersection of two sets? Let us say this is a universal set U. Let us say it has two subsets. Let us say set A, set B. It is set A, set B. Then intersection means common region between A and B. So this is the common region between A and B. So this will be the intersection. So the common elements between A and B is known as intersection. So this will be A intersection B. Now let us see some properties of intersection. So the properties of intersection. The first property of intersection of two sets is A intersection B is equal to B intersection A. It is known as commutative law. If you take intersection from A to B or B to A, or B to A, B intersection A, you will always get the same set. It is known as commutative law. Similarly, associative law is also followed. If I have three sets, A, B, C, I am taking their intersection. If I take first the intersection of A and B, then the result that I will get. After that, I will take intersection with C. Now, if I change this combination, I will take first the intersection between B and C, and the result that I will get, then I will take the intersection with A. I will always get the same set. It is known as associative law. Third property, phi intersection A. Simply, phi has no element, and we are taking the common elements between phi and A. Since phi has no element, so no element will be common. It means we will get phi. That is null setback. Fourth property, if I take universal set and its intersection with A, since we know common elements will be A, because in universal set we have present all A elements there. So its intersection with A will get A back. So it is known as law of universal set. Let us see the next property. Fifth property. If I take A intersection A, since A has same elements between these two, so I'm taking the common element between two equal sets A. Simply it will be A back. It is known as idempotent law. Let us take the fifth one, that is known as distributive law. Distributive law says if I take A intersection B union C, then it will be equal to A intersection B. Then we have to take the union A intersection C. This is known as distributive law. Its second form will be like this: A union B intersection C. It will be equal to A union B, then this intersection, and A union C. A union C. It is known as distributive law. Let us see the third operation, that is known as difference of two sets. Difference of two sets. Third operation is difference of two sets. Let us say I have two sets. Let us say set A is equal to, let us say 1, 2, 3, 4. And I have, let us say set B has elements, let us say 2, 4, 6, and 8. Then A difference B means A minus B. We write like this: A minus B. It is a new set that contains all elements of A, and I have to subtract those elements from B that are common with A. If I see 2 and 2 is common, 4 and 4 is common, I have to subtract these 2 and 4 because they are in common with B. I have to minus B. A minus B. I have to minus them with B. So I am left just with 1 and 3. So it will be 1, 3. So in A minus B, we have to write all elements of A and subtract those that are common with B. With B, they were common 2, 4. So we have subtracted them and we are left with 1, 3. So it means A minus B will be 1, 3. Similarly, if I want to write B minus A now, B minus A, it will be a new set where we have to write all elements of B and have to subtract the elements that are common with A. Since 2, 4 are common and we are left with 6, 8. So 6, 8 will be the answer. Now, if you want to write this difference of two sets in set builder form, so it can be written like this: A minus B, it is equal to set of all x such that x belongs to A, x belongs to A, and x does not belongs to B. So I have to take all elements of A and I have to subtract those elements that belong to B. So this is the representation in set builder form. Now, if we want to represent it in a Venn diagram, so we can see it in a Venn diagram like this. Now, let us see the representation in Venn diagram. Let us say it is a universal set. I have two subsets, set A and set B. So this will be complete A and minus B, because this region is common with B. So I have to subtract it. So it will be A minus B. And this region, it will be simply, we already know it is A intersection B, common region between A and B. It will be A minus B. And this region, will be B minus A. All elements of B, I have to subtract elements of A. Since A are this region, it is common with B. So it will be B minus A. And their union, A minus B, A intersection B, and B minus A. Their union will be complete A union B. So A union B will be equal to A minus B union A intersection B union B minus A. So this was about the intersection, the difference of two sets. Now let us see some properties of all these three operations, general properties, some general results, some results that we'll see from these three operations. Let us move to some results of all these three operations. So some results. Let us see the first result. We can see that the first result, if I set A, I can see that it will be subset, that it will be subset or equal to A union B. Since we know that this will be A union B, that is, it's A, it is B. It will be A union B. A union B is complete this whole. I can say that this A, either it will be subset or it will be complete B equal to A union B. Because if B is contained in A, let us say like this, I have a B here, or let us say it is A here, B is contained inside it. So I can say that then A is equal to A union B in this case. In this case, A will be subset of A union B. So I can say that A either will be subset or equal to A union B. Let us see second result. The second result similarly is, if we take B, I can say B either will be subset or equal to A union B. Same case. Let's say it is A and B. This will be A union B. I can see that B is here subset of A union B. Now, if it is set B and A is inside B, then I can see that B is equal to A union B, because A union B will be complete B. In this case, it will be equal to B will be equal to A union B. So I can say B either will be subset or equal to A union B. Let us see the third result. The third result is A intersection B. It will be either subset or equal to A. Let us say same thing. Let us say it's A union B. It is AB. And if I see A intersection B, it is this part only. So it is subset of A here. Now if I see like this, A intersection B, let us say it is A and it is B and it is A. If I take A intersection B, it will be only this part. I can say that it is equal to A here. So either A intersection B will be subset of A, it will be either equal to A. Let us see the fourth case. Similarly, if we take the fourth case, it will be similarly like this, that B either will be subset or equal to A intersection B. Let us take the fifth one. if A is subset or equal to B, if A is subset or equal to B, then I can see that, and we can see that two results, that A union B, it will be equal to B because A is completely contained, or either it is equal to B or it is contained in B. And if we take A union B, simply it will be equal to B. Let us see this property with the Venn diagram. Since A is subset or equal to B, so if it is B and if A is contained in it, it is subset or it is complete equal. Similarly, if I take A union B, it will be directly equal to B. And if I see here in this second part that if I take A intersection B, A intersection B, that will be equal to A. See, it is A and we take intersection with B, it will be only A. So we'll get A. So let's see the next result. Sixth result. If A intersection B is equal to 5, A intersection B, it is equal to null set. There are no element common. Let us say like this. It is A, it is B. They have no element common. Their intersection is 5. It means that it is null set. We can say, in this case, we say A and B are disjoint sets. So we can say A and B are disjoint sets. Now, if A intersection B is not equal to 5, seventh result. If A intersection B, it is not equal to 5. So there is some region common between A and B, some elements common between A and B. So we'll say them they are overlapping sets. And in this case, we say A and B are overlapping sets. Let us see the eighth result. Eighth result. We can see that A minus B, it is either subset or equal to A. We can just see it through Venn diagram. Let us say it is A, it is B. If I take A minus B, I know it is only this part. So it will be here subset of A. It is subset, it's a part of A. So it will be here subset of A. Similarly, we can see that it is A minus B will be equal to A. A minus B will equal to A when we have disjoint sets. If I take A minus B are disjoint, they are like this. It is A, it is B. Since A minus B, we can say that A minus B in this case, since they have no element common, we are taking A minus B completely A. We will get all elements of A since there is nothing common with B. So in this case, A minus B will equal to A. So either it will be subset or equal to A. And similarly, we have on the same base, we have same result, we have B minus A. Either it will be equal to subset or it will be equal to B. Let us see the next result. The ninth result. If A is subset B, A is subset, or either it is subset or equal to B, then we can see that A minus B, A minus B, it will be equal to 5. It will be equal to 5. We can see it Venn diagram through Venn diagram like this. Like say A is subset of B. So it is B and A is contained inside B because A is subset of B or it is equal to B. Now if I take A minus B in this case, since A has every element common with B, we are getting 5. So A minus B is equal to 5. Let us see the next result. The 10th result. We can say see that A minus B, it will be equal to A minus A intersection B. We can see through it like diagram easy like this. Let us say it is A and B. We know it is A intersection B and it is A complete A minus B. So A minus B, it will be equal to complete A. We have to subtract A intersection B, we'll get A minus B. Let us see the next result. 11th result. We can see that A minus 5. We are subtracting A from 5. 5 has no element. We'll get A. Similarly, if I subtract A with A, the right also will get nothing. So we'll get 5. Now let us see next result, 12th result. What will we get if we take A minus A minus B? Let us see it. How much it will be equal to. If I see through Venn diagram, I have to subtract from A, that is it is AB, it's A, it's B, I know it's A minus B. I am subtracting from A. This is complete A. I am subtracting A minus B from it since I am getting them this region also only. So it will be A intersection B. So A minus B equal to A intersection B. Let us see the next result. If A minus B will be equal to B minus A, the last result, 13th. If A minus B is equal to B minus A, we can see two things here. A minus B equal to B minus A only, it implies two things, either A equal to B or A and B are disjoint. That A and B are disjoint. If A minus B is equal to B minus A, it means either A is equal to B. We can see like, let us say this A, let's say A has elements 1, 2, 3. B has also elements 1, 2, 3. If I take A minus B, B minus A, in this case I am getting 5. It will be 5, it will be 5, so it's equal. So it means 5, 5 equal. It means A and B are equal. So if A and B are equal, A minus B will equal to B minus A because we get 5. Now, if they are disjoint, they have no element common. Let us say this A. A has, for example, 1, 2. B has 3, 4. If I take A minus B, it will be so in this case, if I take now A minus B and B minus A, which case say if I see A minus B, it will be complete A back, and B minus A, it will be B back. It means that they have nothing common, so they will be disjoint. It means that A minus B will be only equal to B minus A only when both are equal. So if A and B are equal, we are always getting 5. They will be, in this case, will be A minus B will equal to B minus A. So we can say A minus B will be only equal to B minus A when they are equal. Now, if they are disjoint, they have no element common. In this case, A minus B will be equal to A, B minus A will be equal to B. Like we can see here, A minus B, it will be complete A, B minus A will be B in that case. But if they are equal sets, if they are equal, then A minus B will be equal to B minus A. So this was about some properties of union, intersection, and difference. Now let us see what is the symmetric difference. The last one, the symmetric difference. Last operation, symmetric difference. If I have two sets, let us say A and B, then symmetric difference A symmetric B. it is equal to A minus B union B minus A. If we see through it Venn diagram, from Venn diagram we can see like this. Like say I have a union, it's A, it's B. I know it is A minus B and it is B minus A. Their union will be a symmetric difference B. So this was about the symmetric difference, and in the next topic we will see now complement of set.